So today I'm going to be talking a little bit about cells in Rust. And feel free to jump in if you have any questions. This is a talk that is aimed at beginners to Rust. So I'm going to try and go over things very slowly. We'll try and build up from some fundamentals, but I'll also try and go through it relatively quickly as well. So do let me know if I'm going too fast or if there's something you don't understand. You can just pipe up and let me know, and I'll try my best to answer your questions. So yeah, cells. What is this talk going to be about today? Well, first I'm going to start with a little story. I just wanted to start with a little bit of motivation for why I decided to do a talk on cells specifically and how I got into this. Then I'm going to talk a little bit about what cells actually are, what cells are available in the standard library, and then we're going to talk about some of the other existing cell crates that are floating around out there. So first of all, this table is uneven and it's being very annoying. Story time. So if you've been to these meetups recently on a regular basis, you probably are already familiar with this story, but I'll recap here. I'm working on a project in Rust at my workplace, and what we do is we basically have a Rust core that is wrapped by clients in various different languages. So we have like a wrapper in Java, one in Python, one in Node, one in PHP, Golang, and essentially, in order to create these wrappers, we need to use FFI. So if you don't know what FFI means, it stands for Foreign Function Interface. And did I hear a question? Does someone already have a question or a comment?
No, that's okay.
Sorry.
Oh, all right. I'll keep going then.
Yeah. Sorry about that. I was just sending a note.
All right. Oh, can you get it, please? Thank you. So FFI stands for Foreign Function Interface, and basically that just means that you can talk to other languages from Rust through like a C ABI. So in our case, we want to talk to Java. We want the Java client wrapper to call into our Rust core. And so the way that that's done is through something called JNI, or the Java native interface. And the way that works is whenever we want to create a Java object or call a Java method, we have to provide some kind of identifier that will state like where this class is. And so some lookup has to happen. And so the problem that we have is that these lookups can, like the time to do these lookups, while it's relatively small, if you're doing a lot of these lookups in a row, then those costs can kind of add up. So we were trying to figure out how to cache these. And so I did a bit of digging around, and that's kind of how I ended up looking into cells, because that's what came up. And so, yeah, this is how I ended up creating this talk. So for those who don't know anything about Rust, or you're very new to Rust and haven't read the book yet, or maybe you've read the book and maybe you weren't really super clear on interior mutability and cells, I'm just going to go over that right now. So cells are shareable mutable containers. That's basically the textbook definition as provided by the actual official Rust documentation. But that doesn't really say a whole lot. Like, obviously you could think of like a variable as being a container, right, in any other language, and you'd be like, oh, but in Python and in Java I can share variables between functions, between threads, right? I can mutate them or whatever. It's not really a big deal. So what does that what does that really mean? So in Rust, as I'm sure most of you have probably heard of already, there's this thing called the borrow checker. And the borrow checker is basically this static analysis tool that checks your code for any memory issues. So, you can have security vulnerabilities potentially if you have your code accessing like uninitialized memory. So it basically just tries to prevent memory errors. So the way that this borrow checker works is that there are two rules. You can have multiple, or you can have, I guess, one or more immutable references to an object, or, this is an exclusive or only one mutable reference to an object. So we'll get into that in a moment. I'll do a quick recap of references and Rust and all that, and how the borrow checker works. But essentially, the problem that this creates is that sometimes you need to mutate an object that you have multiple references to. References are basically just like pointers from like C or C++, if you're familiar with those languages. And so if you have multiple references to a single object and you want to mutate it in Rust, that's pretty much strictly not allowed by the borrow checker. And so cells allow us to sort of circumvent that in a way, in a pattern known as interior mutability. But it's not like it's the Wild West. So
Jonathan, Aaron's asking if you could let him back in the door's locked.
Oh, sorry, what?
Aaron was asking if you can let them back in. The door's locked.
The door is locked. Oh shoot. Okay. I'll go get them.
Yeah, sorry.
Okay, sorry about that. We've got like another 6 people here. So yeah, quite the party now. Anyway, back to the slides. Yeah, as I was saying, cells allow you to mutate objects behind multiple pointers, or sorry, multiple references. But it's not the Wild West. You're not allowed to just mutate things freely. It's not as dangerous as that. Each cell type that Rust provides has its own limitations, and those will help you ensure memory safety while still giving you sort of a controlled way of mutating the object behind the pointer. So if you're not familiar with the borrow checker and ownership in Rust, I have a very quick little rundown on that here. So first we have this struct foo. This is just a struct definition in Rust. You could have fields in your struct, like, I don't know, like this. You could have like an integer in your struct, but I'm not doing that because I don't really care for the sake of this demo. So the way that you construct a value of this type foo is with just foo again. So this is basically the same as doing something like U32 2, like in any other programming language. If you wanted to create like an integer variable, you could do something like that. But anyway, here we're creating a variable named foo of type foo, and it has this single value foo here as well. And then we take ownership of foo by passing it to this ownership function. And so what happens here is you'll see that this is totally fine. There's a bunch of warnings from like unused variables, but that's about it. And so this is kind of what you expect. This function just takes a foo. It does literally nothing. But if you try to call ownership with foo again, then you're going to run into some issues. So now it's going to say use of moved value foo. And this is because we already took ownership of foo on the first call here. So once foo has been moved into this function scope, once this function exits, then foo is deallocated. And so it doesn't exist anymore. So if we try to use foo again here, that's not allowed. And so one thing that you can do to fix that is you can say derive copy here. So this derives the copy trait. You also need to derive clone if you're deriving copy. But essentially, if a type implements this copy trait, that means if you just pass it in again like this, Rust will automatically just copy the value. And so if it gets moved, that copy gets deallocated and the original is still okay. You're still free to use it, and that's totally fine. Of course, there are caveats to that, because what if foo is like a config, right? Maybe it's loaded like some giant config file, and now you have this massive struct. So the problem with that is it's very expensive to, copy really large data structures like that. So you might not want to actually move your data or copy it like this, but instead you might want to borrow it. And so we have this borrowing syntax. It basically allows you to pass something by reference. So this ampersand in front of the variable name creates an immutable reference. And this ampersand mute in front of the variable name creates a mutable reference. Now, like I mentioned earlier, there are two rules that you have to pay attention to when you're writing Rust code with borrows, right? You have the borrow checker here that checks whether you have several immutable references or just one mutable reference. So in this example, this is not okay. And the reason for that is because I'm doing an immutable reference and a mutable reference to the same variable and passing those into this function. So if we try to run this, this will fail. Cannot borrow foo as mutable because it is also borrowed as immutable. However, if we were to say remove this mutable reference requirement and just pass two immutable references, then this is a-okay. There's no issue with that. So yeah, essentially, you can kind of play around with stuff. If you're new to Rust, just go to like the Rust playground. You can just Google Rust playground and find it pretty easily. But yeah, it's also at this play.rustlang.org. And you can mess around with Rust code there and try stuff out, see what happens, and basically just test whether or not your code compiles and get a feel for the borrow checker that way. I guess before I move on, does anyone have any questions? Is there anyone who might be confused?
It might be worth noting that I think if you implement copy, you can't have any heap allocated memory in the object.
Is that true? Maybe it is.
I thought that was true.
I actually don't know off the top of my head.
Yeah, no, that's correct.
Okay. Yeah,
Copy
no, actually, no,
implies
that makes sense. That makes sense. That makes a lot of sense. Yeah.
Yeah, copy implies that you are able to just copy everything across without having to copy things on heap as well.
Right. Yeah. And primitive data types automatically implement copy because they're all pretty cheap to copy over. But yeah, once you get into things like vectors and strings, then you pretty much have to call clone if you want to clone them. And then if you do a clone on something that has heap allocated memory, then you're doing deep copies at that point. So that's another thing to be careful of. And that's a case for moving data instead of cloning. So yeah, that's pretty much everything there. Let's see. Right. So next we're going to move on to the different types of cells in the standard library. So I've got some more examples here. Let's close this. It's kind of in the way. And essentially at the top here, I'm showing the four main cell types that the standard library exposes. So, and these are not the only cell types technically, but we'll get into that later. But first we'll start with the most basic one, which is, well, it's just called cell. And so if we want to create a cell, we just use cell : new. This is the constructor syntax in Rust. And we just give it a value. So here I'm giving it a literal 5, but I suffix it with U32 to specify that it's an unsigned 32-bit integer. And so after that, we call cell.replace. We give it the value 2. And so if we print this, what we should expect is that we will get 2, because if we replace this value 5 with a 2, then if we print it, that the 5 is gone, so we get the 2. So the one thing I really want to note here, and if you're new to Rust, maybe you don't know this yet, but in Rust, when you create variables, you can also specify that they are mutable with this mute keyword. I did show it off in the last playground, although I didn't really talk about it. But yeah, in this case, we're mutating something that doesn't have that mute keyword in front of it. And so this is something that is maybe a little bit weird to get used to at first, but yeah, this is what interior mutability is all about. It's all about being able to mutate things that are not normally marked as mutable. And you can kind of imagine, like, you could have like another struct here, like struct bar, that holds like some kind of cell here, and it might have some other fields too, right? But essentially, if you have a cell in your struct like this or in your enum, then you will be able to do something like let bar equal like bar, and then fill in the fields there to construct that bar. And you can leave this thing as immutable, and you'll still be able to mutate this this cell if the proper accessors are given. So that's basically how that works. One thing that I want to note here is that if you create a cell around something like this foo struct here, which in this case, notice that the only thing that we derive here is debug. Debug basically just lets me print it. But if we do the replace here with another foo, and then we try to print this out, then we will see this error. It says that the method get exists for the struct cell foo, but its trait bounds were not satisfied. So the trait bound that's not satisfied is this copy trait bound. And the reason for this is because the way that the basic cell works is it moves values in and out of the cell. And so some copying is involved, and therefore the copy trait is something that it wants. So we could fix this by throwing on copy here, like so. And oh wait, of course we need clone. And now it's okay with that. But yeah, that might not be something desirable, right? Because like I said, not all data is small enough to be copied efficiently. So that's why what you'll more commonly see in Rust code is something called the ref cell. And so the ref cell is kind of similar. Basically, it allows interior mutability, but instead of moving values in and out of the cell, what it does is it allows you to obtain references through these borrow and borrow mute methods. So don't do this. This is something that I initially tried. I thought this is how you borrowed the value in the cell. No, this just borrows the cell. Don't do this. This doesn't do anything for you. If you want to actually interact with the ref cell the way it's intended, you need to call the borrow method. So yeah, well, here I call the borrow method to obtain an immutable borrow essentially at runtime. So again, basically, the way that ref cell works is it gives you these references, right? It's lending out references to the value inside, but as we know, references have to follow certain rules, right? That's why we have a borrow checker. Otherwise, we run into memory safety issues. And so what ref cell does is it actually enforces these rules, the same rules as the borrow checker does, but it does so at runtime instead of at compile time. And so now we have a little bit more flexibility, but we also have the potential of crashing our program. So for example, if I use this immutable borrow of the cell and then I try to use a replace, and replace mutates the value inside of the cell, right? Then we're going to see that everything goes wrong and we get a big nasty crash here. We get this panic. Also, I'm just going to comment this out for now, just to make sure it doesn't interfere with anything. But yeah, this is this is the problem with ref cell. It's memory safe. Like don't get it wrong. Don't get it twisted. It's the panic is still memory safe. It's just, you know, it just crashes your program. So you're not going to catch as many issues at compile time potentially. And another thing that I should mention is because it has to check all these rules at runtime, there is an associated cost at runtime as well. So your program will run slightly slower. So that's another thing to just you know, look out for. And this also panics for the same reason. I'm not going to run it just to show you, but like there's this borrow mute method, and you know, according to the borrow checker rules, we can't have both an immutable borrow and a mutable borrow at the same time. So that's not allowed. However, if we call the drop function to drop this immutable borrow, then we are actually allowed to do this mutable borrow, and that lets us set the value to 9. And so when we print it later, you'll see that the value comes out as 9. One thing that you should note is that cell.into_inner actually moves the value out of the cell. And so if you don't drop this reference, you'll get another error. And I can just quickly show that as well. Yeah, cannot move out of cell because it is borrowed. Won't want. So next we get into the once cell. And so the once cell, there's a little bit of more complicated logic here. It's not really that complicated. It's just an if-else, but essentially, the once cell lets you initialize a value exactly once, and then it never gets called again, or the initialization never gets called again. So here I actually have an example down below. We have one cell being called with false and one cell being called with true. And what happens is when you call it with false, it ends up in this if case here, the first case, and we call cell.get. So let's just run this and see what happens. So you call cell.get and it returns a none. So the reason why it returns none is because we haven't actually initialized the cell yet. And then down here, after this if else, we just call getter init. And then that initializes the one cell. So it prints init one cell, and then it prints the value that is returned, which is foo. And so, you know, that's pretty much what you would expect. But once we get to one cell true, we get into this else case here, right? And so that's going to call init one cell. But then once we get down to this getter init down here, it's not going to do the init one cell a second time. You see that it just prints foo twice in a row. It doesn't actually do the init twice. So that's something to be aware of, is that you can have this sort of conditional logic where you say, I want to get the value, but I don't necessarily want to initialize it right away. Or like you can actually have conditional logic like that to choose like when you want to initialize this thing. But do be aware that once it's initialized, it's initialized. You can't go back. And that brings us to the lazy cell, which is similar to the once cell, but this just initializes on the first axis no matter what. And it's actually implemented using the once cell. So the once cell is sort of like a more general solution if you need a little bit more control. But the lazy cell is just kind of so it's kind of more convenient for certain use cases, like if you wanted to say cache something, right? You wanted to initialize something once and then just never touch it again. I should mention that just because you initialize once doesn't mean that you can't mutate the value. So there are get and set methods on one cell and lazy cell. I don't show them off here, but they basically do what you'd expect. They let you mutate and read the value from inside the cell. So that's the 4 basic cells. And You're probably wondering, when would I use this? When should I use cells? So they're commonly used when mutating values behind smart pointers. So that's your ARC, your atomic reference count, that you'll see a lot in multi-threaded code, and RC, which is the reference counting pointer. Those are both used for multiple ownership, which we're not really going to get into today, but just be aware, like you'll probably see a lot of multi-threaded code using ARCs. You can also use cells to expose immutable APIs for your libraries while hiding mutations that might happen within the implementation. You can also use cells to create mutable implementations of traits that take an immutable reference to self. And of course, with the once cell and the lazy cell, you can use this for initializing values one time only. And so now I'm going to move on to what doesn't really look like cells, at least in name, but these essentially are also cells. And the book kind of alludes to this as well. So what are these? These are from the standard sync module in the standard library. And they're all locks. So we have the reader-writer lock, or RW lock. We have the mutex, or mutual exclusion lock. We have the once lock, and we have the lazy lock. And all of these are basically thread-safe variations on the cells that we've already covered. So these are only pretty much going to be used for multi-threaded programs. Now, I'm going to use them in a non-multi-threaded context because I want to kind of show the similarities, the analogies between these and the cell variants that I showed earlier. But in general, when you see these types, it's going to be in a multi-threaded context. So first off, we have the RW lock. And the RW lock is basically just a thread-safe ref cell. So you'll notice that it has read methods, and this is basically the same as borrow. So you can have many readers or only one writer, which sounds very similar to what the borrow checker looks for, right? You can have many immutable references to your data or just one mutable reference. So yeah, essentially, it's used in a very similar way to ref cell. Here we have to add an extra unwrap call to deal with, I think it's a result. It's either a result or an option. You probably want to actually handle that properly in your production code. But for the sake of this example, I'm just going to use unwraps. And similar to ref cell, it checks these rules at runtime, or actually, the way that it handles this is a little bit different. So if you try to run this, you notice that the program actually just hangs, and that's intended. If you read the documentation for lock.write, it'll tell you that if you try to do a write while you have reads active, or sorry, these what you get out of calling read is a RW lock read guard, I believe, and same for the write, you get a write guard. But yeah, if these read guards are still around, then this write won't work. So we would have to drop A and B to do that, which is exactly what we do. So this block here of statements, this is a thing that you can do in Rust, by the way, is if you want to make sure that you drop everything within like a certain scope, you can just put all your statements inside of a block like this, and then when it hits the end of the block, it'll just drop everything here, all these variables. But yeah, we will drop A and B. We'll drop those two read guards, and now we'll do a lock.write here. And lo and behold, it works. No issues, no hanging. It prints, and it even lets us mutate it and turn the locked value into a 3. So there you go. That's reader-writer lock. Next, we have the mutex. You've probably seen the mutex before, maybe even in other languages. Pretty common lock to use. It's the mutual exclusion lock. I don't think it really corresponds to anything in particular. It maybe corresponds to ref cell in a way, maybe just like the basic cell sort of too, but it only has one method, which is just lock. And this gives you exclusive access to both read and write the value that is wrapped by the mutex. And so one thing that I want to point out is that if you try to lock twice, this behavior is considered unspecified according to the documentation. And so this will either panic or it'll deadlock. In our case, yeah, it just causes everything to hang. So we're just going to kill that. But yeah. One thing that you should note is that unspecified behavior is not the same as undefined behavior. So undefined behavior is what Rust kind of considers to be like dangerous territory, like not memory safe. Well, memory safety is included in undefined behavior, is what I should say. But unspecified behavior is a bit different. This is like it doesn't really state what's going to happen, but you're still guaranteed to be memory safe at least. And so now we get into once lock, and once lock is kind of interesting because it looks basically the same as once cell. It has this getter init method, and it pretty much behaves exactly the way that you would expect. So if we run this, did I? No, I didn't. Of course I didn't. We run this. You should see that it'll say init, but it won't print init again. And yeah, that's pretty much the same as once lock, or sorry, once cell, with the exception of this here. So this is something that once lock lets you do that once cell doesn't let you do, which is it lets you create, or sorry, it lets you initialize a static variable lazily, but without using any mutation. And this is actually kind of a big deal because if you want to mutate a static variable at all in this language, the compiler will just say no unless you use the unsafe keyword. And the reason for that is because you could potentially try to mutate it from two different threads, and that would create a data race. That's not safe. That's undefined behavior according to Rust. And so that's dangerous. It doesn't want you to do that. So yeah, you can actually initialize this cell variable even though it's a static and it's not marked as mutable. So this is actually a pretty nice benefit of that, is avoiding usages of unsafe. And finally, we have the lazy lock, which behaves basically like the lazy cell, has the same sort of semantics, but of course, we have the benefit of being able to initialize static variables, same as like the once lock. So you can kind of see the analogies there, right? Like this is basically once cell. This is basically lazy cell. Yeah, these are the thread safe variants, and they're pretty useful. So now we're gonna go back to my little story about looking into caching for the JNI identifier. So basically, as it turns out, we already had a solution for this in our dependencies. We have this once cell crate there, and I think this was probably added a while ago. So that's why it's there, because as you'll notice, what I have here at the bottom is the once cell crate is actually something that's been moved into the standard library now. So you don't really need the once cell crate anymore. There are some niche cases for it still, which I'll cover, but essentially the really important functionality from once cell has already been moved into the standard library, which is the lazy lock and the once lock that I showed you earlier. But yeah, essentially, one cell just it does the one-time initialization, and we've actually been using it already, as I mentioned, for integration tests. So our project has a bunch of IT tests that need to spin up a server, like a little like a mock server before running the tests, and we just boot up the server, initialize it once using the one cell, and then after that, all our tests run against that. But yeah, it also seems like this might be a really good fit for caching identifiers as well. But yeah, my point here, I guess, is that we had a solution, but technically we don't even need this anymore. We could actually remove this dependency, and that's something that I'll probably have to discuss with the team at some point. Do you have any questions?
Yeah, I mean, we're using one cell from Tokyo, which is we got the same with the integration test. So we initialize it, and we put the pictures, and then using multiple test cases.
Yeah.
That's what I'm
Yeah. Cool. Yeah, good to hear. Yeah, and here's just the comparison with the standard library. So in case you were still using the one cell crate and you want to migrate to the standard library, here are the corresponding types. So they just had one cell and lazy, and they just put them in unsync and sync modules. But in standard, they actually give them different names: one cell, lazy cell, once lock, lazy lock. So yeah, that's pretty much it. So what's missing from the standard library? Well, basically the entire race module. And so what the race module does is it exposes a bunch of types that let you basically race two threads against each other to initialize a value. And so whoever wins the race gets to actually set the value, and the other one doesn't. And that's useful in some niche cases, but that hasn't been ported to standard yet. I don't know if they actually plan on porting it to standard anytime soon. So yeah, I haven't actually looked into that. If someone knows the answer to that, maybe maybe you can chime in. But otherwise, yeah, it seems like a niche case to me, which is why they haven't done it yet. And then there's a bunch of these other crates that I found. So there's async one cell for when you're writing async code. There's also generic one cell, which I believe is used in no standard projects. So when you're writing code for like embedded systems. So actually one cell, like the one cell in standard already supports no standard. I guess not the one in standard, but probably the one in, there's probably an implementation in core, I would imagine. I'm actually not entirely sure about that, but the one cell crate supported no standard. And apparently this is useful for complex scenarios where one cell's critical section support and the race module are not sufficient. So there are some niche crates out there still for one cell. But otherwise, yeah, there are also a bunch of these other crates here that I found that don't seem to be particularly well maintained. They're not very popular at all. And they seem to be just largely replaced by the standard library's one cell implementation. So you can probably just ignore these ones. But yeah, that's pretty much it. That's all that I really dug up on cells. That's all. That's about as far as I got. I didn't really have much reason to go any further. And I just thought I'd share my findings for people who maybe aren't that familiar with cells at all, haven't used them in Rust. Maybe you saw it in the book and then didn't really think too much of it, or you never really had a use case for it, and so you're curious to learn more. Yeah, if anyone has any questions, now would be a good time to chime in.
At least some of these, like the locks, they have try-lock methods as well, don't they? So you can try.
Yes, they do. Yeah, yes, they do. Yeah. I don't really have too much to say about that, but yeah, they do. They have try-lock methods. I didn't want to get too into like the I guess like the threading aspects of them. Like I didn't want this to be a talk about multi-threading. I didn't want to like pollute the code with too much multi-threading logic and stuff, because I really wanted to just focus in on like those analogies between the locks and the cells. But yeah, in general, you're not going to see locks used in this kind of context. This is just a single-threaded. These are all just single-threaded functions. So yeah.
I have a question. Why would you use a cell? Like one cell makes sense. You have the use case. What is the use case of just using the cell?
And it's breaking the rules of us. Like you can change the,
Yeah,
it's by default mutable.
the use
We are
case.
not defining it mutable, but you can change the value.
Well, there are some. I did cover a few use cases here. So you can create mutable implementations of traits that take that normally would take ampersand self. You can use like a ref cell instead to make it a mutable implementation. You can also use it to expose immutable APIs that hide mutable implementations. I've seen it used with RC in a couple of contexts, particularly with I think older versions of Tokyo. I don't know if it still uses it anymore, but I have seen RefCell in the wild in like public APIs. So
one example would be like a cache where you have some like expensive method on your type that doesn't logically mutate the value of your type. So you want it to take an immutable reference to self, but you're going to compute this big thing and then you're going to stick it in a cache somewhere so the next call is fast. And that cache, you need to mutate it. So that, that's a good spot for a ref cell. Like it's this little piece of state that you're modifying, but you don't want to expose the outside world to that because it's kind of an implementation detail and you're promising to be good about it. So it's just like a little escape hatch for when you need to do stuff like that.
It is only stores from your data type so that it can store the structs and stuff. And the structs will be mutable or mutable.
do we have any other questions, comments? We'll check the chat, see if anyone said anything.
Yeah, I just asked a question about the overhead. I was curious about, like, if I stick something in a cell, have I like increased the size of my struct? And then same question for ref cell. But I think what Chester said makes sense.
I mean, there's obviously the runtime overhead of RefCell already. I think Cell has overhead as well, if I remember correctly. I think they both do.
Yeah, I think there's a count field for the immutable borrows because it has to keep track of how many there are because as you drop them, they go down again. And then I think it's a flag, although they might pack it into the same count field for the mutable one.
The documentation actually says so too. Like if you look at like standard Cell, I believe they mentioned something about overhead here. Maybe not. I'm pretty sure that there is something that says that.
I don't see why Cell would need to have overhead though, because it's just doing a copy. I mean, you pay the cost in terms of time for copying, but in terms of memory,
that's the one I'm less sure of.
Oh
No.
yeah, if you click on Cell itself, like the actual page for Cell, it says at the top that it has the same memory layout.
Oh, okay.
T.
Yeah.
That's cool.
Right. So yeah, this kind of stuff is documented. Yeah, good question.
And then I have one more question that I think I know the answer to, but
All right.
so we have these single-threaded and multi-threaded flavors of these things. Rust is all about, preventing us from making dumb mistakes. What prevents us from accidentally using Cell when we were supposed to use like the mutex version?
Well, it's not sync and send.
Yeah, it's not sync and send. So the compiler will stop you because it doesn't implement the appropriate traits. That There are two traits that Rust implements for every thread safe type. And you can use unsafe to implement them for other types, but otherwise, the compiler will just stop you. You can't generally create data races in safe Rust.
Cool.
So the lazy static crate, can you show us again the built-in cell that you could use to replace that?
That would be the lazy, either the lazy lock or the lazy cell. I think that was here. Yep, that was here. So the author of OneCell actually has in the official docs for OneCell that, yes, this is a replacement for the lazy static macro. That has been deprecated for a while now. So you shouldn't be using lazy static at all. In fact, there was actually an effort to put lazy static into the standard library at one point. And then because, Rust is very, cautious, they're very slow about migrating things into the standard library. And so they actually didn't, and then they eventually came up with OneSlock, which isn't a macro-based solution. And so Burnt Sushi, the creator of RipGrep, said he was very thankful for that. Like he says that's one of the really nice things about not moving things into standard so quickly, is that you don't get issues where you think that this is a great solution, let's just move it right away, and then someone comes up with something way better later on, and it's totally wasted effort, and now you have to deprecate this API and everything. Like, he doesn't like standard becoming a graveyard like it does in some other languages. So but yeah, this is, to answer your question, yeah, this is the lazy cell. This is what you should be using instead. You can also use the OneCell, of course, as well. It's a little bit more flexible. But yeah, the lazy cell is just more convenient. Any other questions? Comments? I don't know if this helped anyone who's actually new to Rust. Did you find it helpful? Cool. All right. Yeah, that's it. I'm just going to stop sharing. Yeah, now we can just chat, talk about whatever you want. If anyone has any questions about their projects, or if they want to talk about anything in particular. I don't know if Chester wants to talk more about typist or anything.
Sure, I guess I can mention it. Been redoing my resume, and I found a template in Typist. It has the same appeal to me that eGUI had to me. That it makes well, Typist itself is very flexible, but the template uses a YAML file for the content. So basically, you can only put in the content file, and you cannot fidget around with messing around styling and all of that whilst you're working on the content, so that the content is separate from the styling, very separate. So it makes it kind of easy for me to focus on one part at a time. That's been a good experience so far. Almost done into the content. I've had the urge to probably make this word in the thing bold, and I'm like, no, really, let's not try to do that, because that doesn't fit into the template. Let's just leave it alone.
Wait, earlier you said it was like eGUI. How's it like eGUI?
eGUI was the same kind of thing for me, because with eGUI, when you start creating the GUI, you don't really, it's more challenging to make the layout look a particular way than just make it functional. So I always end up making it functional first, and then I can always go back and try to style it if necessary. But I seldom never do that, and seldom ends up being okay. And usually ends up being okay. So I just end up not getting nitpicky about, maybe this could be a little more to the left. No, maybe a little more to the right. Maybe they should be aligned this way. No, just align them up and then clear them out, and at the end, it ends up looking okay generally, right?
Yeah.
I've made quite a bit of development on the log viewer program. I might probably try to clean it up, but I don't know when I'll have time. If I have time, I'll probably clean it up and probably do a presentation on it again.
Ooh,
Because it's come a little bit of a way from since last time.
you have a link to the
But
repo?
keyboard shortcuts working now. Huh?
Do you have a link to the repo for people who?
Yeah, sure. I have keyboard shortcuts working now, so that's been great.
Cool. Now this is Chester's log viewer that he's been working on for a while.
Not really. I work on it when there's a feature that I really need that I don't have.
Okay, you work on it
more than twice.
on
then I
and
come
off.
back. Huh?
You work on it on and off then.
Yeah, I work on it when there's a feature I need that I need it more than once. If I need it once, I probably don't need it. I just I try to get by without it. But for like search, for example, I just couldn't get by without search. It was not practical. So I added search. And then after I added search, I realized that I couldn't find why some of these things were matching, because it was like you have so many fields, which field matched. So then I had to add highlighting the matched fields.
And it consumes JSON logs from tracing, right?
Right. Yeah. Well, JSON logs written to a file. It works with files right now.
Right. Cool. I still haven't checked it out yet, but
No worries.
I plan on using it someday.
Yeah. Well, let me know if there's a feature that's not implemented yet that you do need, because I try to make everything self-documenting. Like if you hover over the things, they tell you what the shortcut keys are and that kind of thing.
How close do you think you are to being ready to do another talk on it?
It is mostly almost ready for that. I probably just want to upgrade to the latest version of eGUI, but I'm not ready because I have a conference to attend next month. So
Oh, cool.
So I don't think I can do it next month. And then I don't know how much time I'll have after I come back to prepare the talk. So it's more a function of time than the project not being ready.
Hello, welcome. I'm sorry, but this is a little bit late into the meetup. The talk is already over, so the recording will go up though afterwards on YouTube in the usual place. I'll post the link to it in the meetup comments and also on Discord. Is there anything else? I don't know. Honestly, I'm glad to see that there's a lot of people here. I'm surprised that so many people showed up in person. I was actually thinking of moving these back to virtual because I wasn't sure if people were going to show up, but yeah, people are going to show up.
I think over the summer there were a lot of people busy doing stuff.
Mm.
Hopefully now that it's fall, more people are back in town.
You think people will show up for the next one in person? I mean, I'm a little bit concerned because of the time change is the thing. I think that's this week. It's going to get really dark.
Yeah, I wanted to ask regarding the meetings. So you usually hold them like on a monthly basis, right? Do you have any other events to socialize or like related to Rust in general, or is this like this one going on a monthly basis?
This is on a monthly basis. These used to be run on like a 2-week basis, like once every other week. We changed to a monthly basis because what ended up happening was basically the meetups happened too often. People just kind of ran out of things to say. It got kind of awkward, and then everybody started dropping out until there were only like 3 people left showing up for meetups. So something had to be done. Let's just say.
Okay, I see. Makes sense.
Yeah, no changes planned to the monthly cadence.
And we also have the Discord in between as well, but it doesn't
True.
get used much.
It doesn't get used much. People asked for this Discord and they don't really use
think
it.
it's a good idea.
Sure, I guess.
I think Steven wanted to say something. His hand up.
Yeah, go ahead, Stephen. We can't hear you. If your microphone is not working, then
No, I don't hear him either.
yeah, his mic is not working. Oh, he muted. Like he might be changing microphones.
All right.
We'll give him a moment.
What is the Discord for this meetup called?
We get it.
Good question. Go
I'm
post
just seeing the invite link. That's probably easier.
it. Go post it in the chat.
I will do.
We have the invite link here actually. Yeah.
I see.
Uh,
Well,
he's
I
up.
just heard you a while ago, actually, before I saw your message.
Yeah, we can't hear you, Stephen.
Yeah, I'm not sure.
You can also just type what you want to say in chat, I guess. I do have the chat open right now.
Okay. Any of you guys had any experience with WebSockets and Rust?
I've used WebSockets, but only with like the U framework, which I think not very many people use now. I don't know.
Right. And what was the backend?
Warp.
Warp. Okay.
Yeah.
You were just testing, or was it actual project?
Don't ask me for web projects or advice on web projects.
Microservices.
To repeat the question for the people who are watching the VOD later, the question is, does anyone have any ideas on how to set up or build out a web app from a microservice perspective?
I mean, there's like Axum and a number of other ones. I don't know what the most popular one is.
I feel like Axum is probably the most popular.
Yeah, Axum's pretty popular.
We use Excel.
You use Axum.
Yeah, I tried Actix, but the API was not that good in terms of the way I'm used to. We come from the Node.js background.
Okay.
And then we tried Actix, it was pretty good, but we realized that is super simple.
Yeah, Actix, I remember seeing much buzz because it was really fast.
It is fast.
But then, yeah, a bunch of what I read
Yeah,
said it's easier to use Axum. for
very
cases.
easy. It's not even
Yeah.
1.0 yet, right? Maybe performance will improve, but the API is so simple and that doesn't make it so user-friendly.
Yeah. So Stephen says, I'm currently using Leptos due to its SSR/CSR.
I'm always skeptical of using microservices as a first choice because I feel like they fill a niche when you scale, but to start off with, I feel like they add a lot of complexity that they don't merit.
Yeah, it's always a trade-off. As soon as you have microservices in there, you've got the trade-off of, well, now you have more programs to make sure they're working properly and talking together. Some cases is a clear win, but you have to be prepared that you have to build out more infrastructure, tracing, distributed logs, all those kinds of things that if you just have one application, even if it's multi-threaded, you don't have to worry that much about.
Yeah.
Stephen says, this way I can execute heavy tasks on the server and hydrate it down to the CSR components using the hydrating features of Leptos.
I've been really looking at trying Leptos, but so far, Ego has been meeting all my needs in terms of my front end. So I guess my front end is also pretty simple. But I don't know.
You've been selling the eGUI really hard. I might actually have to switch to it. At some
No, no, no. I'm not trying to sell it. It's not. It's. They say it's not production ready, but I'm using the production anyway. Because it's just making life easier. I think the big thing for me is the mental model is very, very simple. It's all just functions, you know. I know functions. Wait, I've been using those. You know, it's
Yeah.
simple. I mean, I guess there are complications that come up from being able to write code that has to run 60 times per second. So you know, it does add constraints in terms of how much you can do, where, and that kind of thing. But I don't mind. It hasn't been stressful per se. Getting it to work with the async code was, I wouldn't say it was challenging, but I would say that I ran into a lot of issues in figuring out what types should go where and that kind of thing. I think now that I've done it for most of the pages, it's not feeling that hard anymore. Modals are a challenge. That's not a challenge that you expect, but when you rendering everything in real time, you know, I haven't quite figured out a good way to do modals. But for all my use cases so far, I've actually found workarounds, right? I just sometimes have a if function and just pops up another section of the page kind of thing. I've not actually tried to force modals yet. My concern with WebSockets is I'm starting to wonder if I'm treating it like a hammer and everything's starting to look like a nail. Because
sometimes I feel that way too. Yeah, like I'm just like, do I really need WebSockets? But then, yeah,
cross-platform solutions as well. Oh, I'll read it out. Sorry. Stephen said, "I'm looking into cross-platform solutions, and have been playing with eGUI. I find it hard to work with, except I'm suffering a mental model block on how to use it. Oh, well, if you're on the Discord, hit me up. I can definitely walk you through some of my code because I'm happy to explain it. Maybe that might be a better talk than, well, I guess that's a similar talk to what I would have done anyway for the log viewer. I've actually found eGUI to be very easy after you understand the mental model. I don't find the mental model was hard to pick up, but I looked at lots and lots of examples before I started actually using it because I was still trying to decide at that point. And fortunately, or fortunately, it was the first one I looked at in detail, so I don't have a good reference point to compare with the others. But back to the hammer thing with the WebSockets, I need to ensure that when they edit in user profiles, only one person's editing the profile at a time. And I need to interrupt with the currently deployed version of the program, which just basically sets a flag on the user variable saying, I have it locked. Whoever gets to set the flag first locks it, and the next person just can't edit it. But it's just a Boolean flag. And as a result, when you lock it, if the program that locked it crashes, just stays locked until it just stays locked. So there's a force unlock feature, but you know, that's not ideal. But WebSockets, I feel like they fixed that because unless the server crashes, it will unlock because the server can lock it and then keep the WebSocket open. And if they stop responding, well, you know, then they don't have the lock anymore. The server unlocks it.
Thanks, guys, for the feedback. Can you all hear me now?
we can hear you
Yes,
now.
you can.
Yeah, I had to restart my headset. Sorry for that. Yeah,
No worries.
thanks. Yeah, thanks for the advice, and definitely I'm gonna take you up on the eGUI. Like,
Yeah.
I don't know. For me, I tried a couple times to sort of like create a POC, but it's just different dependencies and different things that were going. I did get it up at some point in time, and then it has this, I guess, layout or sort of like layout structure that you have to learn to be able to lay things out. I can't get over that for some reason. I don't know why. So maybe somebody needs to show me how to put together some sort of like, even if it's just like you know, this like a settings control, and and then I think that would really help. Yeah. Thanks for the suggestion.
Yeah, I can definitely show what I do, but what I did was I skipped that step. So I don't actually really understand how their layout system works. I know that it's very flexible and you can do a lot of things with it, but I've just restricted myself to keep it simple, get the functionality working, keep on building a POC, and then I can always redo the front end once I'm done. But I can show you what I did, right? Maybe you don't actually need something very complicated. If you just wanted to hack something together fast, that's because right now my velocity is my primary objective. I want to get a POC completed. So I want to make sure that I build out the front end, build out the back end. Back end is going to stay in Aptix because that's what I started with, and that's what was used in the Zero to Production book by Luca Palmieri. So I'm pretty happy with that. But at least I'm comfortable with it. And the front end, I don't know if it'll stay in eGUI, but eGUI is making it really easy for me to build out a fast version of the front end, except when I get stuck. I get stuck for once in a while, but it's more a matter of how should I structure this as opposed to, oh gosh, this thing can't do it. So like today, I was sitting down trying to rationalize how to deal with the locking. That's not really an eGUI problem. That's a how do I want business logic to work kind of thing. But I had a piece of pen and paper while I was waiting, and I drew out something. I'm gonna try it and see if it works.
Do you have this project open sourced at all?
No, unfortunately, it's not open sourced. I keep on thinking of doing an open source version of it, like the parts that are reusable, but I can't justify not doing work to do the open source version. I'm like, and probably nobody else even wants this,
I kind of want to see eGUI plus the WebSockets plus. I think you're using Axon, right?
Well, there's an example actually. I didn't do it from scratch. So
okay.
The application actually includes a chat service because that was the example I used to learn how to do WebSockets.
Ah.
So I was like, oh, this could just stay.
Fair enough.
So yeah, so the example that they have on the eGUI website, because they built an eGUI WebSocket library. The same people that made eGUI, they made a WebSocket library. And they have an example in eGUI, obviously. And as a result, that made it really easy for me to just copy paste that into mine and mess around with it to learn how to use WebSockets. And then after I had that working, I was like, well, there's no point in ripping all this chat stuff out. I'll just leave it. So I ended up spending another couple of days adding on necessary chat functionality, like, who sent the message and that kind of thing. But it's I think it's turned out pretty okay. I might not be able to open source it, but I can definitely demo it. I don't think that would be a problem.
Okay, cool. Yeah, no, I'd definitely be interested in that because I might just switch. I might just switch over to whatever stack you're using.
Well, I don't know if it's the best stack, but it's definitely easy. And
I'll take
after
easy.
I figure out the problems, then it goes pretty okay because I'm using request for my sending my things from the client.
Sure, everyone. Everyone uses
right. But I need to have it work in the browser because it's I don't native only, it doesn't meet my needs. As a result, I needed cookies because that's how I'm doing my authentication right now. And request didn't support cookies at the time when I started using it. So I implemented cookies in request because I thought, worst case scenario, I don't get through and I just use some kind of wrapper around it. But I kept on going and I didn't bump into any problems. Turns out that there a few people tried before me and they ironed out all the problems. So when I came, it was just, everything just worked. I just plugged it up and connected up all the pieces, copied and pasted some code from the native side and adapted where necessary, and it just mostly worked. There's one part that I couldn't figure out how to implement because for native, they manage the polling for redirects and they have a loop where they go from one redirect to the next redirect and they track the cookies across all those redirects. But in the browser, in the WASM version, you just send a request and the request automatically handles all the redirects for you. So you just get back the final thing. So I don't have a way to track the cookies in between that thing. But that doesn't matter for my use case. So I don't know for other people if that's a problem. But in the browser, when you're doing a WebSocket request, you can only send cookies if the cookies are in the browser's cookie stash. If the cookies you want to add them manually, that's not allowed. You cannot manually modify the headers on WebSocket requests if you're making the request through the browser's API, which is a problem because that's how the cookies are added for the other ones. So when you're making a WebSocket request, I basically just can't send cookies, which means that my authentication gets broken. What I ended up having to do was, while you authenticate, you send a request and you get a token, and then you send your WebSocket request. I validate that IP requested a token. Once that gets validated, then I expect the first message to be that token that I gave you. And that's how I'm doing maintaining my authentication. It's not ideal, but I don't see problems with it, and it's been working so far.
Okay, interesting.
Yeah.
I've never really thought about doing authentication through WebSockets.
Well, for the chat, it's not a big deal, right? Because it was just a test. But for the other things that I need WebSockets for, it's kind of like a real-time spreadsheet editing kind of thing. And that needs to be authenticated. I need to know who made changes, when, and to what. So authentication was not optional for that part.
It would make sense that you'd start by authenticating, and then the beginning of your WebSocket session, you'd send your already authenticated material or something derived from it.
Right, exactly. That's basically what I'm doing. So what I'm doing is, once you're authenticated, you make a request for a token for that particular WebSocket endpoint, and then you connect to WebSocket endpoint. And because WebSocket connections are a lot more expensive than regular requests, I don't want to just let people DDoS me by building up a thread for each request I get. So I first validate that IP address has requested a token, which is possibly a problem, but it's not a problem right now yet. So I'm okay with it because on my network, all the IPs are static. It's an internal application. So for my use case, it works. Then once they connect, then they have to send that thing as a first message so that they can validate that they are the ones that requested that thing from the authenticated API. Then I can continue talking to them after that.
Okay. Well, I think people are starting to drop out now, so maybe we should wrap up.
Stephen, are you in the Discord?
Sorry, what's that, Chester?
Are you on the Discord?
I'm on Discord, yeah.
Yeah, okay. So you can just hit me up there for me to show you how I get through GUI, so I can even help you with your particular problem.
Perfect. And what's your Discord name?
Chester. Well, in that server, my name's Chester, but it's one normally.
Yeah, I
But
don't
changed it to
have
Chester.
the server information for Vancouver Meetup.
Oh, okay. I sent it in the chat again.
Oh, this one here. I see. Okay, perfect. Yeah, okay. I'll add you on there, definitely.
All right, no problem.
Thank you. Appreciate it. All right. Talk to you all. Bye.
All right.
All right.
For coming.
Thank you. Bye.
Bye.
Bye, everyone.